Hello students and welcome back to the ATL online class. We are doing the project on the TinkerCad with the help of Arduino Uno, and today we are going to the next project. And the main component that we have today is a photoresistor that you can see on the screen, that is also called LDR, light dependent resistor. So not much detail we are going to discuss about this. The only thing that we should know how to use it. So this is one of the sensors which depends on the intensity of the light where it is placed. So if it is placed in high intensity of the light, then it will give some different output. If it is placed in dark area, then it will give some different output. So this is how this sensor works, and based on that, the output that is given by this sensor, we can do some. So the very basic project that we can think of, that is automatic street light, where we want to save electricity, because if the electric street lights we have, that must be switched off during daytime, so that the wastage of energy can be prevented. But if we do it manually, that is manually if we try to switch it on and off the street lights, in some time we can forget to switch it off and the wastage of electricity can be there. So there we can use this sensor where automatically the daytime where the intensity of the light is already high, the lights can be off, and when the intensity of the light will go low, like evening time, then automatically the street lights will be on. So the wastage of energy will not be there, and no need to handle those electric lights or the street lights. So that is the basic thing that I'm going to show today, how to use this sensor to make automatic lamp or the light. Let's see how to do it. So for that, the main component that we are taking today is Arduino. When we are taking relay also, single channel 5 volt DC relay we are taking today. We are taking the help of RGB, one bulb of 5 volt and the LDR, and one power supply, external power supply required because we are trying to control the bulb of 5 volts. And other than this, we will take the help of resistors. So let's directly understand how to do the connections, and let's start it. So as usual, what is to be done very first, let's take the 5 volt and ground somewhere on the breadboard so that our work will be easier. So I'm taking this 5 volt on plus line, and same thing has to be done other side, so that the entire line will become plus 5 volt. And ground we can take on the negative line that you can see with minus, which is indicated on the breadboard. And same thing has to be connected other side. So negative with the negative. Okay. Then let's bring it at one place here. And in RGB we have 3 colors, that is red, green and blue, and one is cathode, which is the negative terminal of this RGB. So it can be positive also, but here we have negative, that will be connected to the ground with the help of one resistor. Okay, so let's quickly place it somewhere and take the help of one resistor, because without a resistor if you try to connect, then the reality can be damaged. So next thing is, overall we have the skill, that is how to connect the circuits. You can see this resistor is basically connected to the ground line, that is going to cathode of the RGB. And out of red, green and blue, let's take any 2 colors. So let's take pin number 2 with the RGB for one of the color. So let's take red color with this, and take so this will be the pin number 2. Digital pin 2 of Arduino, and the pin number 3 let's take this color. We will not take all the colors. We just use 2 colors of this RGB. Why we are doing, just to make this project a different one, good also. So let's connect this with pin number 3. So 2 and 3 we have taken, and now moving to the next, we have the bulb and LDR also. LDR you can place it anywhere. How to connect the LDR, that we should know very first. So first of all, it should be connected with the positive one of the end can be connected with this 5 volt. So 5 volt we have on this particular line, that can be connected here directly. So one of the line can be directly connected to 5 volt of this LDR. Second will be going to the ground with the help of one resistor. So let's connect this resistor here, and this should be of 10k that we have to select also. And this resistor should be of 220 ohm that we are not using. So value is also important, and this should go to the ground line. So the ground line is this negative. So let's just connect. So this is done. Now moving to the next, we have the bulb and this relay. So bulb will be going directly to, one will go to direct negative of this battery, and the other will not go directly but it will go to the relay. So this relay has got terminal 8 and terminal 4. So out of this you can connect any one to this bulb first. Let's place it here so that it will do it properly. So you can connect terminal 4 with another terminal of the bulb, and then this terminal number 8 should come back to the battery. So this is up to you how you bring it back to the battery. Then it should come back to the terminal of the battery. Okay. So 4 and 8 numbers of this relay is connected to the bulb along with the battery. Now we have terminal 1 that should go to the ground. So we have the ground line here itself. So directly we can connect to the ground line. And now we are left with terminal 16. That will be the terminal which will be commanded with the help of battery. So what is to be done? Let's bring it to the breadboard first page, and then let's bring it to the Arduino. So Arduino pin number next we can take care. So we can say with the pin number 4 of Arduino we are going to control the relay that will finally control the bulb, and with the help of pin number 2 and 3 we are going to control the RGB, but the main thing is the LDR that we have connected in the circuit. That should also be giving the values or the inputs to the Arduino. So that will take the help of one A0 pin. So what is to be done? The pin which is going to the ground, same pin will go to the A0 also. So what is to be done? Let me shift it here, somewhere up, and this point will go to the A0. So this is the pin of the Arduino A0 that will finally help us to read the value of LDR. With the help of A0 we are going to read the value of LDR. So you should know the one which is going to put down to register, same terminal will go to A0 and other terminal of LDR is just 5. That's all the circuit we have. Let's move to the programming. So in the programming, let's see what is to be done. So overall one thing we have to remember. First of all, we have pin number 2 and 3 which are controlling the RGB, so both must be the output pins. Pin number 4 is basically controlling the relay, that is also must be the output pin. And A0 is basically the pin through which we are going to read the value of LDR, so that must be input pin. So that we need to define. So let's define it quickly and then so define. Very first we have RGB. So let it be LDR for this pin number 3 we are taking. Define LED blue P, that is pin number 3, and define what else we have, that is your relay. So let it be relay, that be pin number 4. And one more we have, that is the LDR. So LDR is basically going to be input by 8 So we have defined all the pins, and now rest we know we have to define the input and output. So So one thing we have to remember, that is out of these components we have LED R output. That's the one. Okay, let's do copy paste so that we can save our time. 1, 2, 4 total. Then we have LDR blue. Sorry, LED blue. Then we have the third one is relay. It's all our output. And the last one is your LDR, which is 6. Okay, so this is done. Programming will be very simple. First, let's read the value from the LDR, and depending upon the value, let's enroll the bulb and the RGB. So, one more thing is we are going to read the value of LDR on the screen. So, serial.begin 96 on close. Let's quickly move to programming. int LDR v. Let's record the value in new variable LDR v. That will be analog. Why analog? Because the values will be given by the LDR will be multiple values in the form of analog. So we take analog. Read. What is to be read? LDR value. LDR. And then we need to display it. So serial.print ln. What is to be displayed here? LDR value should be displayed. And that should be repeated also. So after 1 second, let's see this value be repeated. So the programming is very simple. First of all, we have given the command to the Arduino to read the value from the LDR and save it in the new variable called LDRV. And let's print this value after every 1 second. Now we have to check this. If this value is high or low. So if LDRV, let it be greater than or less than something. So it will be greater than 500. Let me see. Greater than 500 means somewhere we have more intensity of light. Then in that case, what should happen? This bulb should not glow, and LDR only one color should glow. So let it be digital light. Our LED blue. Sorry, red should glow. Okay, digital light. Our LED blue should not glow. Okay, and bulb should glow. Digital light, and that is connected to the relay. So that we define relay that should not glow. So concept is very simple. If there is high intensity of the light, let the red LED be on and the blue LED should be off, that is in the RGB, and the bulb should also be off because it's already there, the light is already there. Okay, so that's all we have, and else what can be done? Else you can just copy paste. So once we copy paste, our time will be saved. And just reverse everything. Low will be made high and high will be made low. So this will be made high. That's it. So if the intensity of the light is high, that is LDR value is more than 500, the bulb should be off. That's why relay is off. Otherwise relay is going on. And LDR different two colors should be on. Just let's see. Okay, so this time you can see the value which is printed here is 54 or something, which is less than 500. So less than 500 means the intensity of the light is very low, and according to our program this bulb should be on. So bulb is already on, so you can see. Now if I click on the LDR, you'll see we'll get different a slider through which we can change the value of intensity of light polygon. Practically it is not there, but virtually we can change it. So I can see the intensity of the light I have made 937 something, which which is recorded by the filter, and now the bulb is off, and you can see the red color of RGB is going. And if I just make the intensity of the light low, so you can see this is, so it takes time somewhere to read the value. Okay. So you can see the value is 54, which is very less than 500. So the bulb is on and blue RGB is glowing. Once we make the intensity high, so it's 908 according to our programming. The value is off, and another color of LED of RGB is glowing. So this is how we can make the automatic speed light, and we can save the limits.